Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 5 in the Access Control Vulnerabilities module, titled URL-Based Access Control Can Be Circumvented. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portsfigure.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy, go down, select the learning path, go down again, select access control, and then go down one more time, and then select lab number 5 titled URL-Based Access Control Can Be Circumvented. Alright, let's get started. This website has an unauthenticated admin panel at /admin, so unauthenticated is a big red flag, but a front-end system has been configured to block external access to that path. Again, the fact that it's a front-end system is also a big red flag. However, the backend application is built on a framework that supports the X original URL header. To solve the lab, access the admin panel and delete the user Carlos. Okay, so our target goal over here is to exploit this vulnerability, so this broken access control vulnerability, in order to access the admin panel and delete the user Carlos. Let's access the lab. And while that loads up, notice that I'm using the built-in browser in Burp, and so all my requests are already passing through Burp. Okay, so a little bit of background knowledge before we solve this exercise. The X original URL header is a non-standard HTTP header that can be used to overwrite the URL in the original request. So let's say if a website has front-end validation that implements access control by restricting based on a URL, but the application allows the URL to be overridden using that request header, then we might have an access control vulnerability. The way to test for that is to first send a normal request without the header and observe how the response is. So if we go to HTTP history and then try to access the admin panel, you could see over here it just says access denied. So let's send this to repeater. This is what a normal request looks like. The next step is to add the non-standard header. So X original URL, and say, I want you to visit a directory that does not exist. So let's say it does not exist, and let's add a few numbers just to make sure it doesn't exist. And let's remove the admin panel over here. We're just visiting the normal page. So what this says is overwrite this URL over here, so the main page, and try to access the directory does not exist 43243. Now we know for sure that this directory doesn't exist, so let's hit send. And here we go. It says it's not found. So if we see something like a 404 or a not found, this indicates that the application supports this non-standard header. And again, if validation is done on the front end and the application allows you to use this header to overwrite the directory that you want to visit, then you might be able to bypass this access control and access the admin panel. So the way we're going to do that is we know that there's an admin panel just because if we remove this completely, again, the original request was /admin. So we know that there is a directory called /admin because it gives us an access denied instead of a not found message. So what we're going to do is we're going to say the main page, and then we're going to add our header again. So X original URL. And we're going to say, I want you to visit the admin panel. So it'll replace this endpoint with this endpoint over here, and we should be able to access the panel if there's front-end validation only. Okay, and here we go. We get a 200 OK message, which means that the likelihood of this exploit working is pretty high. If we go to, let's say, admin, you could see that this is the admin panel, but if we go down, let's see if we could see things in the admin panel, and we can. So you could see over here, we could see a users section, and it says over here there's a Carlos user, and then the endpoint to delete the Carlos user, and the endpoint to delete the other user as well. So let's say request this, shows this response in the browser. Let's copy it and put it in here and hit send, and here we go. This is really the response of the request. Now, if we try to delete, let's say, the Carlos user from over here, it'll tell us that it's an access denied, because again, there's validation that prevents you from performing requests that should only be performed by an admin user. However, if we re-exploit this vulnerability over here, so let's send this to repeater again. If we re-exploit this vulnerability over here and use it in order to delete the Carlos user, we should be able to bypass these access controls. So we're going to copy this. This is the endpoint that we want to visit. And we're going to put that in X original URL. Now we can't put parameters in here, so let's put slash and make sure that's written correctly. So we can't put parameters over here, so what we're going to do is we're going to copy this entire thing, delete it from over here, and put it in here. So this will append it to this request right over here, hit send, and we get a 302, so my guess is it probably worked. So let's follow redirection. Now it's trying to access the admin panel again without using the X original URL, and so it's going to say access denied. However, if we just visit the application again, hit enter, you should see that we've successfully completed the exercise. And here we go. It says, congratulations, you solved the lab. Now to absolutely confirm that we did solve the lab, we could just go back to this request over here where we request the admin panel, hit send, and we should no longer see the Carlos user over here. And we don't, so the only user that we should see is the other user. And you could see over here, the Carlos user used to be right over here and it's no longer there. So we successfully completed the exercise by exploiting the vulnerability manually. Now let's script it in Python. Since this is an unauthenticated vulnerability, this script is going to be pretty small. Since we don't have to log in, all we really have to do is perform this second request over here. So this request with this specific header, and then it should delete our user. All right, so as usual, the first thing we're going to do is import the requests library, which allows us to perform HTTP requests. Next, we're going to import the sys library, which allows us to obtain command line arguments. And then the URL lib3 library, we're going to use that to disable certificate warnings. So disable warnings, URL lib3 .exceptions .insecure request warning, and we're going to set proxies to be equal to our configuration in burp. So any HTTP request should be sent to 127.0.0.1 port 8080. That's where our proxy is running, and same goes with HTTPS requests. They should be sent to HTTP 127.0.0.1 and port 8080. All right, this looks good. Next, let's start creating our main method. So if name is equal to main, then call the main method, and we'll define the main method right over here. So def main, if the length of sys.argv, so the length of the command line argument, is not equal to 2, then print the usage instructions. So the user didn't run it correctly, so we want to help the user to understand how to run it correctly by printing the usage and example instructions. So usage is the name of the program and URL, and we take the name of the program from the command line argument. This is argv0, and we also want to print example instructions, so plus example, and we're going to say www.example.com, and again sys.argv0. Okay, this looks good. The last thing we're going to do is exit the program because it was run incorrectly. And I have a spelling mistake right over here. It should be print. All right, so if the user runs it incorrectly, it'll enter this piece of code over here. Now let's assume the user runs it correctly. We're going to start our session object. So request.session. We don't necessarily need it for this one because this is an unauthenticated vulnerability. However, there's no harm in using it. And then we're going to say URL is equal to sys.argv1. So we're taking that from the command line. And we're going to call a function called delete user, which exploits our vulnerability and deletes the Carlos user. Okay, let's implement that function. So def delete user takes in the session object and the URL. The first thing we need is the delete Carlos user URL. And that takes in the URL of the application plus the URL to delete the user. So if we go to our second request right over here and we go back, this was the request that we performed in order to delete the user. So the URL was this one right over here. Let's copy that and put it in here. Now for this request, we also need to set headers because the main way of exploiting this vulnerability is using the X original URL header. So we're going to set it right over here, X original URL, and that header is equal to this right over here. And this looks good. So we're going to say R is equal to s.get. It's a get request because it's a get request right over here. It takes in the delete Carlos user URL, set headers to be equal to headers. So this right over here, we're going to set verify to be equal to false because we don't want to verify TLS certificates, and proxies to be equal to proxies so that it sends this request to my proxies just in case I need to debug it. All right, this looks good. Next, we need to verify if the user was deleted. So we're going to say R is equal to s.get and URL. So what we're doing is we're essentially just visiting the main application. So verify again is equal to false and proxies is equal to proxies. And then we're going to set the response to a variable called res. And we're going to say if this string right over here, so the congratulations you solved the lab string, if that string is in the application, that means we've successfully completed the exercise. So if it's in the response, then print successfully deleted Carlos user, otherwise print could not delete Carlos user. All right, this looks good. So essentially all this script does is it performs this request right over here. So this request right over here, which is a GET request, it goes to this endpoint right over here and it uses the X original URL header in order to bypass the access control and successfully delete the user. In order to verify that we really deleted the user, we visit the main application, so the /endpoint, and then we grep for this string over here. If it's available, that means we successfully completed the exercise, otherwise we didn't. So let's try and save, and I'm noticing over here it's not saving. So what I'm going to do is I'm going to shut this down and reload it. All right, I had to shut it down and then reopen it again in order to save it because Visual Studio was being a little bit annoying. So now let's test our script. So terminal, new terminal. Then we're going to say Python 3 access control lab05.py, and we need the URL of the application. My guess is it timed out, so we're just going to open up a new one. Let's copy that, put it in here, and hit enter. And here we go. It says it successfully deleted the Carlos user. So if we go right over here and go to proxy, you could see the first thing it did is perform this request. It got a 302. And then what it did is it visited the main page and it looked for the string congratulations, you solved the lab. It found it. And so it confirmed that we successfully deleted the Carlos user. Alright, so we successfully completed the exercise by first exploiting the vulnerability manually and then scripting it in Python. In the next couple of videos, we'll look at more complex cases of broken access control vulnerabilities.